Today's lesson is on proportional relationships. Proportional relationships are a relationship between inputs and outputs in which the ratio of the input and output is the same. So it's a relationship between inputs and outputs. And the relationship is the same. In this example, we want to determine if the relationship is proportional. So we are comparing the time in hours and the distance traveled by Mario's car trip. So if we look, we can compare that in 1 hour, Mario traveled 50 miles. And in 2 hours, Mario traveled 100 miles. And in 3 hours, he traveled 150 miles. And in 4 hours, he traveled 240 miles. If I reduce each one of these, 150 is already in simplest form. 2 over 100 reduces to 1 over 50. And 3 over 150 reduces to 1 over 50. And 4 over 24 reduces to 1 over 60. Now if I look at these ratios right here, in order for it to be proportional, they all must be the same. And if I look 150, 150, 150, 160, the last one is different, therefore they are not all the same, so it is not a proportional relationship. We can do the same thing by comparing prices. For example, this is an advertisement for tomato prices. If I look, I could get 2 pounds for $3, 4 pounds for $6, or 6 pounds for $9. So if I write those as a ratio, I have 2 pounds for $3, I have 4 pounds for $6, and I have 6 pounds for $9. Again, reduce to lowest terms. 2/3 is already reduced to lowest terms. 4/6 reduces to 2/3, and 6/9 reduces to 2/3. Since all of them are exactly the same, they are all equal to each other, then yes, this is a proportional relationship. Example 3. Jenna earns $12 per hour making bracelets. She uses the function E equals 12H to track her earnings, where E represents earnings and H represents number of hours. Make an input-output table and graph your results. Does the function have a proportional relationship, and explain? So we're going to begin by creating an input-output table. And we're going to choose our own inputs and outputs. Our input is what we plug into the equation, and so the equation we're using, the input is H, and the output is E. That's what we get for our equation. So because we're talking about hours, I'm not going to use any negatives. So I'm going to start with 1 hour. If she works 1 hour, she makes $12. If she works 2 hours, she makes $24. If she works 3 hours, she makes $36, and 4 hours is $48. Now, I'm going to go ahead and graph this, and I'm going to count my graph by 2's. So at 1, she's going to be 2, 4, 6, 8, 10, 12. And at 2, she's going to be 12, 14, 16, 18, 20, 22, 24, etc. So I'm going to go ahead and graph my line, and mine's not as exact as yours will be because you're using paper pencil. Now it says, does the function have a proportional relationship? So I want to look at the relationship between H and E. So in the first one, my relationship is 1/12. My second one, my relationship is 2/24. The third one is 3/36. And the fourth one is 4/48. If I reduce these, this is 1/12. 2/24 reduces to 1/12. 3/36 reduces to 1/12, and 4/48 reduces to 1/12. So they are all the same. Therefore, my answer is yes, and my reasoning is because all of the ratios are the same. In this example, it says the ratios of all the inputs to the outputs in a table are 1/4. Is this relationship proportional? Well, the definition of a proportional relationship is that all the inputs and outputs are the same. So since the inputs and the outputs in the table are all 1/4, we can say yes, this is a proportional relationship. Okay, for this section I want you to go ahead and answer questions 1 through 3 in your notebook. And when you have finished answering the questions, pause the recording, and then when you have finished, hit play and check your answers. So at this time you should pause the recording, answer questions 1 through 3, and then hit play. At this point you should have answered the questions yourself. It's number 1 says, how can you determine if a relationship in a table is a proportional relationship? The answer should be that all the ratios of input to output should be the same. So you should have the ratios of input versus output should be equal. So something to that effect. Number 2, the ordered pairs are a part of the same proportional relationship. Find the value of x. Well, we know that the relationship would be 2 to 5 would have to equal 4 over x. So we can cross multiply, or you can look at this yourself and see that x should equal 10. And number 3 says a baker sells 3 rolls for $5 and 6 rolls for $8. Is the relationship between the price of selling 3 rolls and 6 rolls proportional? Explain. So we get 3 rolls for 5 and 6 rolls for 8. If I reduce that, that gives me 3 rolls for 4, and these two are not equal, so no. Example number 4. Make an input-output table for the function y equals 4x and graph the function. So this is my input, my x, and my output is my y. So since I'm just graphing it, I'm going to go ahead and plug in values for x. So -2, -1, 0, 1, and 2. When I plug -2 into that equation, I get 4 times -2 is -8. 4 times -1 is -4. 4 times 0 is 0. 4 times 1 is 4. And 4 times 2 is 8. Then I'm going to graph this on a coordinate graph. I go -2, -8, which it doesn't fit my graph, so I'm going to do -1, -4, and 0, 0, and 1, 4, and then 2, 8 doesn't fit my graph, but I do have 3 points, so that's enough to graph it. And you're going to use a straight line. I'm going to pretend that I have a straight line and graph.